Good morning, my dear students. My name is Xu Ting. I'm from College of Transportation Engineering, Chang'an University. In this chapter, we will introduce the urban transportation system. The urban travel modes for residents consist of private cars, bus, taxi, mass rail transit, and other non-motorized traffic modes. The following table is the characteristics for different modes. The cost per passenger car is high, while its capacity is low. The public transport is environment-friendly. The highway road transit is suitable for long-distance travel. However, its construction cost is rather high. Look at this figure. The automobile ownership in China is increasing continuously in recent years. By 2019, the number of private cars had reached 207 million in China. The appearance of automobile makes people's life more convenient. People can travel, go shopping, and go to work by private cars. The private cars can reduce geographic constraints. Travelers are more free from their schedules. The basic features of automobile include design size, power performance, the braking performance. Design size of vehicle includes length, width, height, and wheelbase. Power performance includes the maximum speed, the starting time, the acceleration speed, the climbing performance, and so on. Braking performance including the braking distance, the acceleration speeds, the constancy of braking efficiency, and the braking stability. These characteristics of automobile affect the geometry design of the road. The road capacity is also related to the vehicle design and braking performance. The urban road network comprises of urban expressway, urban arterial road, and side roads. The figure shows the road network planning of Beijing. Different types of roads are marked by different colors. Urban expressways are intracity expressways that are designed to smooth the traffic flow and improve the travel efficiency in the city. The features of expressway are as follows. More than 4 lanes, full access controlled. Design speed is from 60 kilometers to 100 kilometers. Urban arterial road is a high-capacity urban road. The primary function is to deliver traffic from sub-arterial to urban expressway at the highest level of service.
The Regional RailLink Rail Systems team have designed and installed the systems that enable trains to run on the new tracks. A number of different technologies must work together to ensure the network operates safely and reliably. The operation of a train network begins in the control centre. Train controllers sit in a control centre full of computer monitors. Here they can control and keep an eye on all train movements in the network. The central computer system processes information received from the train controller and various pieces of technology installed across the network. It uses this information to regulate the movement of trains by operating coloured light signals. While the train controller and central computer system are the brain of the train network, fibre optic cables form the skeleton. Fibre optic cable installed throughout the network connects all the different pieces of technology together, allowing them to communicate with each other by sending signals along the cables. Axle counters are devices installed onto the track which detect train movements. After a train passes, signals from axle counters are sent through the fibre optic cables to the central computer system. Signals are the coloured lights which tell the train driver when to go or stop. Information processed from the central computer system is sent to signals along the track, informing the sequence in which the colours are to be displayed. A train driver uses coloured signals to drive the train safely along the tracks. The different colour patterns displayed on signals will tell the train driver to stop, to go, and at what speed, among other information. Train radio systems have been installed along the network and allow two-way communication between the train controller and the train driver. This technology allows communication through radio waves. Train protection warning systems are safety devices installed on the track. If a train passes a red signal, the device will send out signals to automatically activate the train's brakes. Along the network, pedestrian crossings are installed to allow safe crossing of the railway tracks for pedestrians and cyclists. The crossings are fitted with train-activated gates and alarms to improve safety. The technology installed along the track and processed by the central computer system helps to supply passenger information on train platforms, such as passenger information display boards informing passengers when the next train is arriving. Other technology which the rail systems team have installed at train stations include hearing loops, providing announcements for customers with hearing aids, public address systems announcing trains arriving on the platform, CCTV cameras, and Myki machines and Myki readers. The Regional RailLink Rail Systems team have worked hard to install the technology that will enable trains to run safely and efficiently on the new tracks.
Because of their relatively high accessibility, many major roads face large amounts of land use, urban development, making them significantly places. An urban sub-arterial road connecting urban arterial roads to areas from different development places and carrying traffic directly from one part of a region to another. A side road is to connect a line between sub-arterial road and streets, serving for local transportation. The figure illustrates a relationship among mobility and accessibility of urban roads. The urban expressway has the highest mobility but poor accessibility, which is mainly used for long-distance trips. The side roads have lowest mobility but the highest accessibility. Intersection plays an important role in the urban road network. The intersection defined as two or more roads in different directions intersect, which is an integral part of an urban road system. They can classify it into at-grade intersection and interchange. The features of the grade intersection are low construction cost, wide scope of application, traffic conflict areas. The features of interchange are high construction cost only for urban expressway and no conflict areas. Now, let us have a look at classification of parking lot. According to vehicle classification, there are motor and non-motorized vehicle parking lot. According to the service objects, there are special and public parking lots. According to land use, there are permanent and temporary parking lot. According to the site location, there are roadside parking lot and off-roadside parking lot. The traffic flow includes uninterrupted traffic flow and interrupted traffic flow. The interrupted traffic flow can be represented by three main features: volume, speed, and density. Traffic volume is the number of traffic identities passing through a certain place, a certain segment, and a certain line in period of time. Speed is the average speed of the traffic flow. Density is the number of vehicles in a certain length of road. The equation is a classic one for describing traffic flow. Q is the average volume, V is the average speed, K is the average traffic density. Greenfield's linear model comprehensively describes the relation among three elements of traffic flow. There are important parameters. The maximum flow is represented by Qm. The critical velocity is represented by Vm. The critical density is represented by Km. The density of traffic jam is Kj. Free flow velocity is Vf. The interrupted traffic flow can be evaluated by the queue length and delay. Factors affecting delay are drivers and pedestrians, driving level, psychological characteristics, compliance with laws and regulations, vehicles, road conditions. This is the calculation of line capacity. Lane capacity is related to time headway and space headway. Average space headway equals to the sum of vehicle lengths, the driver, braking reaction distance, the braking distance, and the safety distance. Nowadays, new energy vehicles and intelligent connected vehicles are the hot issue for future development. Intelligent connected vehicle is equipped with advanced onboard sensors, controllers, articulators, and other devices. It integrates modern communication and network technology. The new technology aims to realize the purpose of safe, comfortable, energy-saving, efficient driving and place the drivers to operate vehicles. Okay, that's all for today's class. Thank you for your listening. See you then.